Today we go hunting. What? Were you looking with such an imploring eyes at me? Okay, I'll rephrase. Today we'll go hunting apparently scary looking monsters. Not understood. Okay. We heard a lot of theories last class, and those concepts, those ideas has been integrated to form a theory by which we can solve or approach problems relating to them. And today we'll take down, I call them apparently scary looking monsters, one by one, especially the typical ones, which are scary ones, and let's see what happens. And we'll have the same quick calc sections again. And you are with HaveFun&Learn, and I'm KP Datta. If you're new to this channel, please, of course, subscribe, share, and comment. Not to spam me only. Saving these videos, saving the notification will help you in knowing when these videos are being uploaded by me. So we move on to hunting apparently looking monster, right? Let's go. Yes, welcome to fun time, and we solve our first problem today. This guy looks pretty innocent. Let's see. Okay, see, the problem says in triangle ABC, right angled at B, AB is 24 centimeters. BC is 7 centimeters. Find out sin A, cos A, cos C, sin C. So for that, we need the value of AC. So let us first find out the value of AC. Who else? Pythagoras will help us. Okay. So by Pythagoras theorem, AC square is equal to AB square plus BC square. Understood? This is Pythagoras theorem. We replace the values. So AC square is equal to AB square is 24 square plus 7 square, and this gives you, let us find out 24 into 24 our quick calculate. Is it correct? 576. 576 plus 49. So that is equal to 625. So we can write AC to be equal to plus minus 25. Now we take the positive value for obvious reasons. So we have got 25 centimeter as AC. Correct? Now we got to find out the ratio. First, sin A to question number 1. Now we remember sin is some people have. The perpendicular here we are considering angle A. So perpendicular here is BC and base here is AB. So sin A is equal to people have, that is equal to 7 by 25. Right? That's the value of sin A. Number 2. Cos A is curly brown base here, hypotenuse, which is 24 by 25. There you get sin A and cos C. Now the angle changes, it becomes C. Right? Now the perpendicular is AB. Right? So, part 3. Cos C. So now this is the perpendicular, right? We are referring to this. So this will be the perpendicular. So, and so this will be the base. So curly brown here, base by hypotenuse, which is equal to 7 by 25. And then number 4, sin C is some people have permanent, some people have. So perpendicular by hypotenuse, which is 24 by 25. Am I correct? Yeah. So these are, so as far as the first sum, this goes well. Any questions? Okay, we move on to our next problem. Okay, we come to question number 2. Now, before solving question number 2, I think it is pertinent to let you know that we've done an extensive video on the theories and concepts associated with this kind of problems. The link is in the description box. Please have a look and then come back. That will make things easy for you. So coming back to the question, right? Now the question says, given 15 cot A is equal to 8, find sin A and cos A. It's not a monster, looks simple. Let's see. So we'll write 15 cot A is equal to 8. Therefore, cot A is equal to 8 by 15. Right? We know that tan A is reciprocal of cot A. So we can write 1 by cot A. So from here we can write tan A is equal to 15 by 8. Right? Since we want to find out sin A and cos A, that involves the hypotenuse. So we need to find out AC. So before doing that, let us see where we stand. Now if you refer to the figure, this will be equal to turned permanently black. So perpendicular by base. Right? That means implies that 15 n by 8n is equal to P by B, that is equal to what? BC by AB. BC by AB. Okay. Now explanation for this n. See, I told you in previous class also, if you compare the length of side BC, then you cannot say it is equal to 15 units. So what we have to do is put a multiplier so that things becomes true for whatever value of n is, right? So we write, it implies that 15n by 8n is equal to BC by AB, right? Understood? Now see, we can now relate, right? So we can write BC is equal to 15n and AB is equal to 8n. Correct? So far so good, right? Now what we'll do, we'll try to find out the value of AC, right? So AC square is equal to AB square plus BC square, correct? So we get AC square is equal to 15n, is equal to 8n whole square plus 15n whole square, which boils down to AC square is equal to 64n square plus 225n square, right? So that gives you AC square is equal to 289n square, correct? So AC will be equal to plus minus 17n. So we take the positive value. So we get 17n here. Is that understood? Right? Now here we will give the solution. Right? So we know the sides. So they want sine A. So sine A is some people have. So perpendicular by hypotenuse. Right? That implies sine A is equal to 15n by 17n, right? n cancel out is equal to 15 by 17, right? So we find out the cos n. So cos A is equal to curly brown here, base by hypotenuse, right? That is equal to 8n by 17n. So that is equal to n cancels out, 8 by 17, right? Correct? So here we write down the answer separately. We get sine A is equal to 15 by 17 and cos A is equal to 8 by 17. Right? Is that understood? Clear? So now we move on to question number 3. Now we come to question number 3. See, it also looks innocent, not a monster. It says, in a triangle ABC, right angled at B, the ratio of side AB to AC is 1:√2. Find the value of 2 tan A and 1 plus 2 tan A divided by 1 plus tan square A. Great. So let us first note down or mark out what we know, right? So it says AB is to AC is equal to 1:√2. Okay, fine. So what we can do is we can mark out the sides. So AB will be N, that means 1N, and AC is √2N. The N is because, as I told you previously also, the reason is same. It's a multiplier. Okay. Now, since we need tan square, let us see what you got. We got to find out BC because tan is turned permanently back perpendicular by base. So, applying Pythagoras in triangle ABC, AC square is equal to AB square plus BC square. Correct? So if we replace the value of AC, we get √2N squared is equal to AB is N square and BC square is unknown. Right? BC square is unknown. So we can write 2N square minus N square is equal to BC square, right? So from here we can conclude N square is equal to BC square. Thereby we can say BC is equal to plus minus N. So we'll take the positive value. So we get BC as N also, mean 1N. Right? Now we find the value of tan A. Tan A from this triangle is turned permanently black. So perpendicular by base, where is AB by BC. Right? So we put the values. AB is equal to N and BC is also is equal to N. So N cancels out, it is equal to 1. So we find out first the value of 2 tan A. This value we find out. So 2 times tan A is equal to 2 times 1, which is equal to 2. Right? Now we find out the value of tan square A. So tan square A is equal to 1 squared. So 1 squared, which means 1. Correct? So 1 plus tan square A is equal to 1 plus 1 is equal to 2. Correct? So we know the value of tan square A. We know the value of twice tan A. So we put the values up there. So twice tan A by 1 plus tan square A is equal to 2 divided by 2, that is equal to 1. right? So this is the answer, correct? So before we go to question number 4, we go over to quick calc, our new section. Second part of our new section, quick calc. Let's go. In the last episode of quick calc section, I gave you a ready-made tool to calculate the square of two-digit numbers. Today I'll give you the way to calculate faster the squares of three-digit number, right? Let's have a look. Suppose I want square 105 squared, right? So divide it into two parts. Like you draw a line from here. Draw a line from here. So there are two parts, one here, one. Now draw circles like this. Correct? Now first you square this number. Square it. So you get 0, 1. Right? Now you square 0, 5, which is 5. Correct? So 25. Okay? Now what you do, you multiply, and this value is 5. And then 2. So 1 multiplied by 5 multiplied by 2, that is equal to 10. So you write 10 here. So the answer is 1, 1, 0, 2, 5. Check and tell me. That's correct, right? Now we take up another value. 225 squared, right? So we divide it into two parts. We'll divide it into two parts. So, right? Square this one. So 4, 0, 4, right? Square 25, 625. So here you cannot write 3 digits, right? So what we'll do, we'll write here 25 and carry 6. Okay? Now 2 into 25 into 2. So that will give you 2 into 25 into 2, which is 4 into 25 is equal to 100. So 100 plus 6, 100 and 6. So you write 0, 6 here and you carry 1. So you add to this. So this becomes 0, 5. So 5, 0, 6, 2, 5. Don't worry, we'll do one more here. 215 squared. So divide into two parts like this, right? So you got 3 lines here. This can have, this line, this part can have 2 digits. Not more than that. Whatever, otherwise we carry. This part again can have 2 digits. And this can have multiple digits, right? So first we square this, right? So write here 0, 4. Okay. Now square 15. 15 square is 225. So we cannot write 3 digits, so write 25. And the other 2 is carried, plus 2. Okay. Now 2 into 15 into 2. So 2 multiplied by 15 multiplied by 2 is 60. Plus 2, 62. 2 that we carried. So 62. So your value will be 46225. Check. That's correct, right? So the third example. So we take up a third example. So 413 squared. So we divide into 2 parts, right? Like this. And write 3 lines. This place can have 2 digits. This place can have 2 digits and multiple digits here, right? So let's start. 4 square, right here, 16. Okay? 13 square is 169. 13 square, let us follow that our method, right? So 9, 0, 1, 1 into 3, 6. 9, 6, 1, 169, right? So 169, 69 we write. And 1 we carry. Right, now 4 into 13 into 2. For 52 into 2. That is 104. That carried 1 plus 1. 105. So 2 digits can be written here, 0, 5. And this one you carried will be 1 added here. So 16 plus 1 is equal to 17. So the number is 17, 0, 5, 6, 9. Check. So that's all for quick calculate. Next class, I will give you the way to calculate 2-digit numbers with 2-digit numbers. Multiplication of 2-digit numbers with 2-digit numbers, and then multiplication of 3-digit numbers with 3-digit numbers. Okay? So that's all for quick calculate. Now we come to question number 4. It's a good one. Very good one. See. Let's start, right? First, we find out, we say that we can, whatever is given, OQ minus PQ is equal to 1 centimeter. 1, right? So we get OQ is equal to 1 plus PQ. Okay. Now in that triangle OPQ, right angle at P, if we apply Pythagoras, we get OQ square is equal to OP square plus PQ square, right? Fine. Now see, OQ is equal to 1 plus PQ. We replace here. 1 plus PQ whole square is equal to OP square plus PQ square, right? We expand this one, A plus B whole square formula. So we get 1 plus 2 PQ plus PQ square is equal to OP square plus PQ square, right? So these two cancel out. So we get 1 plus 2pq from here is equal to OP square. Now OP is given, so you can write 1 plus 2pq is equal to 7 square or 49, right? So from where you can write 2pq is equal to 49 minus 1 equal to 48. So you can write pq is equal to 48 by 2, which is equal to 24, right? So you got the value of pq, this is 24, right? Now from here again, OQ minus PQ is equal to 1. So OQ will be equal to 1 plus PQ, which is equal to 1 plus 24, which is equal to 25. So OQ is equal to 25, right? So OQ 25, right? Now things to done. See, we have one sine q. Sine q means the perpendicular is this one. So sine q is equal to, some people have OP by OQ, which is 7 by 25, and cos q, curly brown here, base by hypotenuse. So PQ by OQ, which is equal to 24 by 25. This is our set of answers. Okay, hope you enjoyed the class, and this will be all for the solution to problems I was looking for. I think this is good enough for the time being. I'll put a cheat sheet with the description box. You can download for practice and have fun. Till next class, we meet again. Bye-bye.